Good morning. Today we're going to talk about domain, range, end behavior, and interval behavior. We've already talked about 3 of these things, so interval behavior is going to be a little bit new for you. But if you were away yesterday or you didn't quite understand what I was doing yesterday, I'm going to go back over the domain and range real quick with you. Okay, so remember, domain is all your x values and range is all of your y values. And we're going to talk about this notation, okay? If you're not talking about real numbers, you are just going to be talking about a small set of numbers that would be in the domain. So if we look at the endpoint here of this graph, all right, that point is at -5, -3. If I graphed it right, 1, 2, 3, yeah. All right, so now you're only talking about your x's in your domain. So x is greater than or equal to 5, right? Because all of your x values are going to go greater than or equal to 5. All of these x values are greater than or equal to 5. So that's the part that we use. If you see this part right here that has the x such that, it means absolutely nothing. You can ignore it. All right, so all you really need is x is greater than or equal to -5. All right, but sometimes you're going to see that notation in your life. It really doesn't mean anything at all. All right, so if we're doing range, now we look at our y value. And all of our y values are going to be greater than or equal to -3. If we plot any of these points on here, they're going to be greater than or equal to -3. So that's why we have to put that for our range. We don't need to really do the complicated stuff that I showed you in the beginning of the year. That's going to come at a later date when you're in a higher math class. So let's go and graph this equation right here. Actually, this is not a good one to do. This one is though, all right? Let's go graph this equation and then we'll talk about all of these things that we need to notice about it. All right, so I made a table based on the table on my calculator, and I'm going to plot the points that I can see. So some of them I can get on the graph. I don't think I'm going to be able to get 112 on the graph, so I'm not going to graph it. So we're going to go through and we'll graph -5, 0, 5, -4, -3, -3, -4, and then it goes and becomes that. All right, so the graph kind of looks like this. Okay, so we've got to go and talk about our domain and our range and our all kinds of other things. Okay, so let's start. It's usually a good idea to start with the vertex. So go ahead and label your vertex. All right, and I should not have put away my table. Let me show you the table again. All right, if you go in your table, you know this is going to be a minimum, right? So, because it's at the lowest point. So we're going to look for the smallest y value. Well, -3, -4 is my smallest y value. So my vertex is at -3, -4. All right, now I can erase my table because now we're going to use our vertex to do almost everything, okay? The domain, now here's a hint. The domain of every quadratic is always going to go on forever and ever off, kind of to the left. If it were a little wider, you can see it. And it's going to go on forever and ever to the right. So anytime you have a quadratic function, it's going to be all reals. And you can just write it as all reals. You don't have to worry about the infinity symbols and things like that. Now the range is going to be based on where your vertex is. So let's label our vertex. -3, -4. All right, a range is a y value. Okay, so we're going to do y. Well, my y value of my vertex is -4. So we're going to decide, are they greater than -4 or are they going to be less than -4? Since this is a minimum, all of the values are going to be greater than or equal to -4. That's it. That's how you write your range, okay? You can do the y such that, you can do the little squigglies. That still means the same, okay? All right, so we've already decided that it is a minimum, all right? Now we're going to use our vertex again to find the axis of symmetry. Since the axis of symmetry is an X line, a line that is vertical, all right, X is equal to whatever the X value is of the vertex, which is going to be -3. There you go, you're done with that. Now you got to go down and just find the x-intercepts, which if we had our table out again, you would see you would have a -5, 0. Anywhere where y is equal to 0 is an x-intercept, right? And then we would have a -1, 0. That's basically all we need to do, right? So the big picture, the domain of any quadratic is all reals, and the range is based on the y value of your vertex. All right, we're going to go on and talk a little bit about end behavior and a little bit more about interval behavior. So let me scroll through this real quick. All right, here's end behavior. All right, end behavior describes how far left and how far right something is going to go. Okay, so remember this. X approaches infinity, all right? That means on the right-hand side of the graph. What's going on the right-hand side of the graph? Okay, well, it's pointing up. So when it's pointing up, you're basically going to say y approaches infinity on the right-hand side of the graph. All right, let's talk about the left side of the graph. X approaches -infinity. All right, that means left side of the graph. All right, well, what is going on the left side of the graph? It's pointing down. So y is approaching -infinity. If it kept going and going and going, it would go to -infinity. All right, so let's play around with one of these. I don't really like that one. All right, let's try this one. Go ahead and graph this graph in your calculator and let's look at it. Okay, so your graph kind of looks like this. It goes off the window a little bit, all right? So let's talk about the left side of the graph, all right? The left side of the graph is going down, pointing down, okay? So we need to write that in the proper kind of format, okay? So y is approaching, what's y doing? Y is approaching -infinity if it's pointing down, okay? Now, on the right-hand side of the graph, it's also pointing down, okay? So again, y is approaching -infinity, all right? Let's talk about the domain. Now, before we can find the domain and range, we've got to find our vertex. Well, actually, we don't need to find our vertex to find the domain. What's the domain of every quadratic? All reals, all right? That's pretty easy, but we do have to describe the range. Since we don't see the vertex, we need to go into our table. So take a minute and go into your table, and you should get it. Now I'm going to guess that my vertex is somewhere wherever x is 1, 2, 3, 4. Somewhere around there. Don't go scrolling all over the place. So scroll until you get where x is equal to 1, 2, 3, or 4. Uh-oh, we have a problem. All right, let me show you what we got. We got this. And we've got two values for a maximum. We've got 2 is at 12, and 3 is also at 12, okay? So that's not going to give us our vertex. We've got to go do the shortcut method here, and we've got to go find it by putting it into this formula. X is equal to the opposite of b over 2a, all right? So we want the opposite of 5, so -5 over 2 times -1, all right, over -1. Oh, I'm sorry, 2 times -1 is going to be -2, all right? Well, -5 divided by -2 is 5/2, or 2.5, okay? So our vertex is going to be at 2.5, and whatever else we get. So I'm going to change my table to count by 0.5s, because I want to see where my x is 2.5. So go in your table set, all right, table set, and you want to go here where it says triangle table. You want it to count by 0.5s. So let's go change it to count by 0.5s. And now you go in your table, and when you get to 2.5, you see that your y value, okay, is going to be 12.25. All right, so now our range has to do with this number right here, okay? So our range is y in relation to 12.25. What is that going to be? Well, I think everything's going to be lower than 12.25 because the whole graph is lower than 12.25, so it's going to be less than or equal. All right, that was a little more complicated. I'll probably do that one with you in class. All right, so let's go and look again. Let's go look at not just end behavior, let's look at interval behavior. All right, interval behavior describes where it's increasing and decreasing. So I'm going to try to graph this one real quick. Okay, that one was not a good one to graph, so I went on to the next one to graph this one because you can see the vertex. Now, since your calculator is already set to count by 0.5s, it's going to be very easy to find your vertex in your table, okay? So I'm going to plot some points, so I already did plot them, okay? So I've got, in my table, I've got, all those points right there. I think it's going to be like 0, -6, all right, 0, -6. I'm going to go to the negative side here, -1, -4. All right, now if you notice, -1.5 is going to give me a -3.75. That's the highest value of all my y's. So that's going to be my vertex. Okay, so make a note of your vertex here. So your vertex is going to be at -1.5 and -3.75. Okay, so now once we have that, we want to know where is it decreasing. Okay, it's pretty simple if you think about it. All right, look at this. The graph is going up from left to right, so it's increasing here, all right? And then over here, when it gets to the top, all right, then it's decreasing from here. This is where it's decreasing. All right, so all we do is we have to write the interval, okay? So it's decreasing from, now look, you're here, we're going to talk about our x value now. This is -1.5 and -3.75. So it's decreasing from -1.5 to infinity, because it's just going to keep decreasing. All right, and it's increasing, all right, it started increasing at -infinity, and then it stopped increasing at -1.5. Okay, that's really all you do. You talk about where is it going up and where is it going down. We have time to do one more. Let me see if I can find one that we can see pretty easily. Let's try this one, I'm not sure. Okay, so I had to change the last number so we could see it, otherwise it was going to go way far down. So go ahead and plug that into your calculator and let's see what we can find. Okay, so I went into my table, I graphed a few points, found that it's very easy to find the vertex of this one, okay? Because obviously it's going to be a minimum. So we're going to go and plug in, all right, so we just need to remember 6 and -16, all right? Or you could do the shortcut method of finding it, because really all you need is the x value. So if you do x is equal to the opposite of b over 2a, you're going to get 12 over 2 times 1 is 6. There you go. So you need the x value. So it's going to be decreasing. Now look, it's starting down here. Now this is going down a hill, right? Whee, going down a hill. So you're going to go from -infinity, because we're only thinking left and right, to 6. So it's decreasing from there to there. Now, if you were down at the bottom of the hill and then you started going up the hill, you would start going up the hill at 6 and stop going up the hill. You would never stop going up the hill, so you're going to be at infinity. Okay, so that's basically it for interval behavior. It is kind of complicated, but you do need your vertex in order to find it. All right, so you're going to do this exit ticket, and I'm going to leave this on the board for you so that you can graph it and find all of the things that you need to find for that.